Hi everyone, this is Giovanni and your STEM technical director or advisor, however you want to call me. Today I'm going to be explaining a little bit of Arduino and giving you a little bit of hints that I see while doing the labs in the club at the Corona del Mar Middle School. So I would like you to improve your techniques and achieve better results with the Arduino stuff. So welcome and thank you for watching this video. Right here I have a board, an Arduino board. This is an Arduino Uno board, very popular, and I have a couple of other things that are basically gonna help us with the setup. I have a proto board here, a small one. I got a vase, like a plate to hold both things together. I have a switch. I have some jumper cables, different lengths and different colors as well. I have 4 LEDs, green, and I have a couple of resistors here. So let's see how it works. Okay, so one thing that I want you to understand is the hardware that is behind the Arduino board. So it's really simple, but let's review for a little bit the hardware so you get a better knowledge of this piece of board. So on this side we have the USB connector, which is being obviously connected to a USB cable, and this is the port of communication between the board and the computer. So basically it has two purposes. The main purpose is provide the power to the board. So the USB carries 5 volts, 5 volts and ground, and that's the power that we use to power up all the electronics in the Arduino Uno board. And the second function of the USB cable is obviously the communication via USB between the board and the computer. That's the communication channels that we use to download the sketches or programs into the Arduino chip, which is nothing else than a microcontroller, Atmel microcontroller. In this section over here we have the power supply. So the power that comes from the USB sometimes is not regulated, or the main function of this section is we can use this jack connector, so we can power the board also with an external power supply. So if we don't want to use the USB cable, or if the board is going to be placed in a different place, different than the near to the computer, we can use a battery and power the board using this connector. So all this section over here is basically a voltage regulator, a couple of capacitors to filter the signal, the DC signal, and to provide a nice and clean 5 volts to the Arduino environment. This one over here is the crystal oscillator. So is the one that oscillates. This one is the one that this chip Atmel over here, I think is at 10 mega 16U, which is the in charge of the communication between the Arduino and the computer. So this one basically provides the clock frequency for that chip. And there is a small crystal oscillator on this area over here, which is this one that I'm pointing right now. That one is the 16 megahertz oscillator for the Atmel ATmega 328, which is the main brain of the board, which is basically this one that I'm pointing right here. Is a microcontroller. So a microcontroller is you can think of a microcontroller like a small computer, like a small tiny computer, which has everything to take decisions and to perform small tasks. So it has a small memory, it has a communication bus, it has a ROM, sometimes they call it flash memory. So well, that's the place where we store all the programs, and it has all the peripherals so we can communicate in and out with the external world. And these two headers over here, that one on the top and this one on the bottom, are the connections between the Arduino environment and the external world. So we have several kind of connectors. We have digital ports, which are marked here in the board as digital, and we also have some analog ports, which are down here in this area. This section over here is the power, so we have access by using these terminals here, or headers. We have access to 5 volts, we have access to ground, and there is also an output of 3.3 volts in case we need to power like a small sensors or anything like that. And on this corner right here, we have a reset button, which is basically a reset that sends some signal to ground and resets all the microcontroller for a short period of time in case we have some problems in the software or we need to perform some maintenance or something like that in the board. So we just press the reset button like here and release it, and the board should go to the default state or initial state. So that's the hardware. That's the basic hardware, and let's get started with the lab. Okay, so the first lab that any Arduino beginner person starts with is the blinking LED. The Arduino board has one LED, well, it has a couple of LEDs, but the one we're going to be using is this one over here, the one pointing right here, which is connected to the pin or to the digital output number 13. So that's the one that is right now on the board, ready to be used, and we can start using that one. But I'm going to be placing my own LED green one here in the proto board section, so we have a better visualization of the lab. The first thing I recommend to do is to power up the breadboard that we have here. So in order to do that, we have to use 2 jumper cables like this one. Please follow the color code for the jumper cables. I recommend using a red one for 5 volts and black for negative or ground. So please check in the Arduino board, check right here, and look for the 5 volts output of the board in the headers. In this case, if you can take a look here, is right here, this section here. So just plug one red cable to that 5 volt connections, sorry, it's this one over here, and then hook it up to any of these lines in the breadboard. Is a continuous connection in all these holes from this one to this one. As you see, is a red line here that has a positive sign in this section. So just plug the cable in that one, and then you have a connection between the 5 volts of the Arduino board and your breadboard. Now we are going to connect the ground signal. So following the same approach, let's look for the ground signal. If you see there are 2 grounds in this header, so just choose the one that you want. Any of those is a valid connection, and plug the other end of the cable to the negative of your breadboard like that. So by doing that, we already have 5 volts coming from the Arduino board into our breadboard, and we have the capability of using those 5 volts to power our electronics in this breadboard. Okay, now I'm going to connect the LED. So please notice that the LED has 2 leads, and there is one that is shorter or one that is longer than the other one. So the longest one is the positive terminal, also called anode, and the shorter one is the cathode. So anode means that is the positive terminal, and the cathode means that is the negative terminal. So just open up a little bit the LEDs of the LED, so you have some spacing in between these two, and you can get an easy connection in the breadboard. So just use the section, one lead to the top section of the breadboard and the other lead to the bottom section of the breadboard. So I'm just gonna plug this LED here, as you can see. Just apply a little bit of pressure nicely, and it's in. So now I'm going to connect a resistor in series with that LED, just to limit a little bit the current that is going to pass through the LED. So just look for the same column or row, however you want to call this. So if you plug it into the same row like this one, this resistor is going to be connected to this terminal of the LED, and use the other end of the resistor down to ground. So you see that is that negative terminal here in the breadboard, so just hook the resistor to that one. Now I'm going to connect the positive terminal of the LED here using this jumper cable, yellow in color, and I'm gonna look for the pin number 13. If you see here, it's gonna be this one, this one right here. So that's pin number 13. So now we have pin 13 to the positive or anode terminal of the LED. The cathode is connected to a resistor, and the resistor goes to ground. And now we're gonna power up the bottom section of the breadboard. So I'm gonna use again one red cable to connect the 5 volts to the bottom section of the breadboard right here, and I'm gonna use a black cable to connect the ground or the negative to this section. So I think it's done. So it's really fast. As you can see, we have power in our breadboard, and now we have an LED connected in series with a resistor, and the yellow cable is going to be connected to the pin number 13 in the Arduino board. So let's power this up and see what happens. Okay, so this USB cable is hooked up to my USB port in the computer, and the other end is going to be connected to the Arduino board. So I'm going to plug this in. As you can see, the computer makes a sound that is recognizing something in the USB port. And now my board should have 5 volts. So let's check real quick with my multimeter here. I'm going to see if we have 5 volts. So as you can see, I have 4.8 volts coming in the USB power bus, so that's good enough. And let's download one sketch to the Arduino board. So as you can see, when I start downloading, this LED flashes for a little bit, and there we go. We have a blinking LED coming from the pin 13 into our LED. As you can see, this little yellow LED is also blinking in the board. I'm gonna try to zoom in so you can see. So this one right here is blinking, and also our big green LED. So I'm just gonna to show you that it is working and I can control this setup. I'm just gonna change a little bit the timing in the blinking. I'm gonna make this blink a little bit faster, 10 times faster. I'm gonna change it right now. So I'm uploading the new sketch, and as you can see, the LED is blinking 10 times faster. It's blinking basically 100 milliseconds, so 10 times per second, on and off. And conversely, I can also make that blinking really slow. I'm gonna set up to 3 seconds so you can notice the change. Let me change the code here real quick. Okay, it's going down, and here you go. We have a blinking LED, 3 seconds on, 3 seconds off. So that's the very first lab with a blinking LED, and it's working right off the box.